I'm struggling to learn quantum field theory using AI because the AI regularly gives wrong information.
Oh no. Which AI are you using?
I'm switching back and forth between DeepSeek, ChatGPT, and Claude.
And are they all giving you wrong information?
I think so. Got this note here. Let me see. I don't know. How can I reveal it gradually so that you don't get spoilers about what the next line says? Okay. AI regularly gives wrong information. This is, maybe I'll make the font even bigger for you. So here, this is as big as I can get.
Right.
Oops. For example, it'll say that all particles are actually excitations in a continuous field, and then talk about the anti-commutative properties of Grassmann-valued algebra and how that exactly models the anti-commutative properties of swapping two particles, which lead to the Fermi exclusion principle. I think this is saying you have different types of particles. Some are fermions and some are, I think they're jitters bosons. And fermions, you can't have two particles that occupy the same location, whereas bosons you can. So fermions are things like electrons and protons, like they're matter basically. So when you have like matter in one location, you can't have another particle of matter at that same location. Like it takes up space. Whereas bosons are like more...
Are you setting up a really elaborate math joke?
Maybe. Bosons are more like forces. So like electromagnetic, the electromagnetic particle, which is a photon. Like so you have magnets, like they're sending these photons around to... And they can be in the same spot. Two of them can be in the same spot at the same time.
Okay.
But so this is saying, I guess, like I'm going through my notes from memory, so I might get some of this wrong, but I'm looking here. It's saying, so commutative property in math is the idea that like if x plus y is going to be equal to y plus x, right? So we say addition is commutative. You can swap and you'll get the same answer.
Right. As is multiplication, yeah.
Yeah. But here they're
weirdly,
saying
percentages.
Yeah, that's right. But here it's saying that Grassmann-valued algebra, which is a different operator, you can take a different set of operators, right? Like you have normal algebra with plus and multiplication and addition. In Grassmann-valued algebra, it's anti-commutative, meaning you get a different answer if you swap them. And they say that this is the right way, or I guess the right mental model that to think about Fermi exclusion principles, which is saying that you can't have two particles at the same time. So that's what the AI is telling me, right? And I'll be like, wait a minute, if fundamentally all you have is excitations in the field, then fundamentally you can't tell where one particle begins and where another one starts. And it isn't always meaningful to talk about swapping two particles, right? Like, so I don't know if I skipped a step in my notes there, but in quantum field theory, particles are derived concepts. In the same sense of, you can say like your hand is a derived thing, and then more fundamentally they're made of atoms, right? There's quote unquote no such thing as a hand, there's just atoms, and then the atoms can be arranged in such a way so that, maybe you call the organization your hand. And quantum field theory says there's no such thing as particles. There's a field, and then there could be an excitation in the field like this, and where the excitation is, where it's higher energy, you say this is where the particle is. Okay. And it's not at a point, right? Like you can think of, I think you can think of it as a probability of locating a particle at that location when you take a measurement. So like here, if you try to measure, it might say 0 basically, right? Like or very near 0. Like you check if the particle is there, and it's not. Here, if you check if the particle is there, it is very likely to be there. So you say, oh yeah, the particle's here. But here also, if you check, you might find it there. So that's the quantum fuzziness of not being able to know the exact position of the particle. I think this is my intuition, and so I'm checking it with the AI, right? You see, is this? And I'm talking with the AI. I'm saying, here's my understanding. Is it right? Is it wrong, or whatever? So at some point, it's talking about like swapping two positions of particles, and you can't do that or something like that. Like, so you have two particles here, and if you swap them, you get a different answer or something like that. But I'm saying, like, if they're pretty close together, you might get something like this, right? And then it's like, it's hard to say, like, do you actually have two distinct particles, or you just have like one kind of particle that's smushed out around as you bring them closer and closer together like that. So that's where I was saying it's not always meaningful to talk about swapping two particles. So I have this like, it's basically me telling you, I don't understand, right? This doesn't make sense to me. Like, what am I missing? So the AI says, you're right. We're not literally swapping particles. What we're actually swapping is measurements at two different locations. So I think it's saying like, it's trying to say like, if you do, if you have a scenario where you have a particle here and a particle here, you might predict one outcome. But if you swap them, you predict a different outcome. So they're not interchangeable like that. They're not commutative. And I'm saying like it doesn't always make sense to talk about swapping. So then now it's saying, oh no, you're not swapping the particles, you're swapping the measurement, right? So I guess it means like if you measure here, then you for a particle, and you measure here for a particle, you get one outcome. But if you measure here for a particle and then you measure there for a particle, you're gonna get a different outcome. Is what the AI says. And then I'll say, wait a minute. In practice, when you make two measurements, you're not only making them at different points in space, but also different points in time, right? Like you have to measure one particle and then you measure the other particle. And then if you use the Copenhagen interpretation for quantum physics, that's the idea that there's a wave collapse. Like when you measure something, like particles are in a superposition, then you measure something and then it collapses until you only have like one possible outcome. Like when you take the first measurement, that causes a wave collapse, which will necessarily affect the expected outcome of the second measurement. So how can you talk about swapping two measurements, right? Like if you're measuring them in a different order, you're doing a different experiment in a sense. So you should expect a different outcome, even if you could swap two particles. Like so what I'm basically saying is the intuition the AI is giving me doesn't prove that that you can't swap two particles. So the AI answers me. It says, you're right, but the Copenhagen interpretation is now considered naive, and most physicists prefer the decoherence interpretation, where a system is continuously leaking entanglement. So I think what the AI is saying is like the Copenhagen is like when you make a measurement, then there's a collapse. And I think what the AI is saying is that instead, like it's continuously collapsing in a sense, like it's continuously leaking out this collapse because all the particles are interacting with each other, right? There's like the Copenhagen interpretation puts too much emphasis on consciousness, like a conscious or a sentient observer. But you can think of like if a photon bounces off an electron, the photon quote unquote observed that electron, and this is like all the particles are continuously bouncing against each other and decohering against each other in that way. But this doesn't, like, my point still stands though, I feel like, right? Whether you take the Copenhagen interpret or the decoherence interpretation, you still have the problem that measurements are happening in some sequential order, and the first measurement is going to affect the outcome of the second measurement. So how can you meaningfully talk about two measurements, swapping two measurements? Like whether it's macroscopic, like humans, like looking at the particles, or whether it's a photon that bounces off this, electron and then bounces off that electron versus bouncing off the second electron, the first electron. And then it'll be like, you've run out of free tokens in your free tier. So I'll be like, well, fuck you.
Oh no.
So that's my experience trying to learn quantum physics using AI.
Yeah.
My next notes here. Hang on, I'll just bring this over here. Font is a bit smaller. Weird mixture of sycophancy and hallucinations that make it hard to make any progress on the topic. Sort of glad that I'm knowledgeable enough to spot bullshit, but sad I'm not knowledgeable enough to actually learn what the truth is. Comparable to speaking to a college-age, overconfident male that repeats things he doesn't fully understand.
That's how it feels.
I think so. Like I get that a lot, for example, when arguing with people on Reddit or like that's how the AI, and maybe it makes sense because maybe the AI was trained on Reddit dialogue, but
Probably was, yeah.
But it's like, it's telling me stuff and I'm like, it's trying to, it acts like it knows, right? Like it says, I know quantum field theory, let me explain it to you. So I was like, okay, I don't know quantum field theory, explain it to me. So it explains it, and I'm like, your explanation doesn't make sense, or it has holes, or something doesn't work, and then it'll sort of like backpedal. Like it was constantly saying, "Oh, you're right," the AI, and then it tries to say something else, and that still doesn't make sense. And then and so it's frustrating. So I'm like, how do I know anything you're telling me is true, right? Because nothing you say makes sense. Like,
yeah.